Welcome to the AI Research Roundup. I'm your host, Alex, and here we take a look at some interesting developments in AI research. Today, we're discussing a paper titled MESA Text-Driven Terrain Generation Using Latent Diffusion and Global Copernicus Data. So, traditionally creating digital terrain often relies on procedural methods, which can be quite complex and require a lot of expert input. This paper presents MESA, a different approach. It uses a diffusion model trained on large-scale global remote sensing data. The goal is to generate high-quality, realistic terrain directly from text descriptions, making the whole process more flexible and data-driven. They also released a large dataset to support this work. And speaking of resources, this image actually shows the project's GitHub page. So the authors didn't just release the dataset, they've also made their code public. You can see here, they provide the implementation, instructions for downloading the pre-trained models from Hugging Face, and even a Colab notebook. That makes it pretty easy for others to try out MESA themselves, which is always great to see. And this figure, it gives a nice overview of how MESA actually works. You start with a text prompt, like the example here describing forests and mountains in New Zealand in November. This text prompt is used to condition the diffusion model, which then generates two things at the same time. It outputs an RGB image, that's the visual appearance, and also a DM, the elevation data, which gives the shape. And combining those gives you the final 2.5D terrain, like that rendered mountain scene you see on the right. Okay, so that previous figure showed the MESA generation process, and this one gives you a sense of the data it was trained on. This map shows the global coverage of the major TOM dataset they used. The main landmasses you see represent areas where they have both the optical Sentinel-2 images and the elevation data, the DEM. The green areas have only optical images, blue only elevation, and black means no data, so it's trained on data covering a huge portion of the Earth's land surface. Right. So we saw the huge dataset MESA was trained on. In this table, it shows some results. Specifically, it demonstrates how changing the random seed during generation affects the output. You can see for each text caption, like broadleaf forests and hills in Germany in August, they generated terrain using 3 different seeds, 42, 50, and 666. The resulting RGB images and DEMs are clearly different, but well, they all still match the description of forests and hills in Germany. This shows MESA can produce a lot of variety for the same prompt. Okay, so we just saw how changing the random seed gives you variety. This table looks at something different, specifically how changing the text prompt itself influences the terrain MESA generates. You can see they use these little icons, a tree for biome, a mountain for geology, a flag for country, and a calendar for the month. The top row shows the full prompt, and then in the rows below, they remove different parts, like taking out the month, or the geology, or the biome information. It shows that things like biome and geology seem pretty important for getting realistic results, while the country or month information might be less critical sometimes. It really demonstrates how the different parts of the text control different aspects of the final terrain. And speaking of data, this table looks at how pre-processing the training data itself affects the results. Specifically, they trained MESA twice, once using the original Sentinel-2 satellite images, and once using images where they tried to correct for harsh shadows. So you can see the comparison here. The columns on the left used shadow correction, the ones on the right didn't. Looking at the RGB images, well, the ones trained with shadow correction generally look a bit better. Maybe less visually distracting artifacts from those really dark shadow areas. The DEMs look pretty similar, but the visual quality seems improved. So yeah, it seems like even how you prepare the training data, like dealing with shadows, can make a difference in the final visual quality. Overall, MESA is a really interesting approach, using that massive global dataset and diffusion models to generate detailed and varied terrain just from text descriptions. This kind of controllable world generation is super useful, not just for creative tools, but also potentially for things like environmental modeling. Well, that's all we have time for today. Thanks for tuning in to the AI Research Roundup. I'm your host, Alex.